So now, following on from the last movie, let's go and look at comparison conditions by example. And I've already copied all the samples into SQL Developer. I like to demonstrate by example because it facilitates in the learning of the material for the novice, where you actually see everything happening in practice rather than just looking at diagrams and syntax structure and so on and so forth. You actually see it happening. It helps people to understand enormously. So in this case, what we have is a query on the left and a query on the right. As you can see, this is very similar to previous examples. In fact, it's exactly the same. But we're demonstrating that we have a subquery in this query here. It is actually a subquery because this select statement is a self-contained expression, and we have a subquery on the right. So we could run this query and we get that result. And here we're actually saying not equal, so find all the shows that are not equal to this set or subquery on the right, which is basically everything. And obviously we can use greater than to do a range check. And now let's go down here, and we've got another query on the left, and we've got two queries in the where clause saying where subquery equals subquery. Self-explanatory. Just run it. Gives you a specific result, which really shows that what you're doing is you're selecting something from the category table where the category on the left is equal to the category on the right, which happens to be both the same, but it's a demonstrative example. In this case, we're saying not equal. We'll either find different data or we'll find nothing at all, because we can't find something where category 6 is not equal to 6. Essentially, we're saying find all the data where 1 is not equal to 1. Well, 1 is always equal to 1. Although there may be some mathematicians who could prove otherwise. In our case, we like to keep it simple. Here's a range check with a subquery checking against another subquery in the where clause. Here's a like comparison where something like subquery. Here's another test saying where something is not like that same subquery. Note that in the case of like, I'm actually using row num1, so whatever data I'm finding in this query, I'm only ever going to pull a single row. Well, let's do this. Run this query, play. Okay, it runs that query there. What happens when I do this? Row num1, when Oracle runs a query internally, what it does is it pushes out the data through a memory mechanism called a cursor, and it assigns an internal generated row number, RONUM. You can access it using row num, as you can see here. You can access it, and in fact that's going to make me push the text around. We don't want to do that. You can rearrange the text like that in SQL Developer. Don't want to do that right now. What this will do is find the first row in the set of this query as executed down here. So we run this again. So we're always finding the same pattern. You can't like against multiple patterns. That would be very confusing for Oracle. In fact, if we did this and run this, it gives me an error. It tells me it has to be a single row subquery. So we'll Control Z that because we don't, Control Z again to get the entire thing back in there. So let's go further on. Here again, this is the same query we've seen in previous examples. We're simply saying select statement where in select statement, subquery where in subquery. Just run it. And as I said, we can use exists. It's been somewhat removed or now currently ignored in Oracle. What used to happen was exists allowed correlated queries and in did not. So what you had was a situation where in would always pass all the elements in the subquery, and exists would actually stop when it reached the values that you needed. So exists was technically faster than in, but now you can actually use correlation using an in operator. So exists has kind of fallen by the wayside. That's a little bit of a tangent, but it is relevant. So now here we have between subquery, run the query. And between simply gives me everything between the minimum and the maximum category IDs. Guess what? All the data. Again, it's just a sample. And here we're saying between subquery and a literal value. You can do that too. And then we've got examples of any. Find every category ID that is any of these values here. Essentially everything. That is some of these. Doesn't have to be all or any. This is all. Implies that it must be everything. So the result we get from here is a whole lot of nothing. And saying not equal to all obviously gets me everything, because we're looking for it to be all elements. If it's not, then it's nothing. The reverse.